Hi guys, this is a Test Electronics video overview of our prober style fixtures and what features are available for them and the types of probers that are available so that you can make a good decision for your specific needs of your product. So let's start with sizes first. So these are available in 2-inch, 4-inch, 6-inch, 8-inch, and 10-inch high. Width starts at 6 inches and goes in increments of 2 inches, 6, 8, 10, 12, 14, all the way up to 36 inches wide. Now we only stock 6 to 22. Anything larger than 22 is custom made, and it takes about a week to do that. The depth, we stock these 15-inch fixtures and a few select 25-inch fixtures deep. So this is 15, they go to 25. The size we stock, the deep ones, is 16. 16 inches wide by 25 inches deep. Otherwise it takes a week to make those as well. Okay, so that covers the easy part, the different sizes that are available. Now, the next thing I want to cover are the type of press plates. This is an adjustable press plate, so you can loosen up these slides and adjust it this way, adjust these individual pins sideways, and get the exact press down location you need. Now, other types of plates are the rods and the edge. And the rods plate is basically a Lexan cover, an anti-static Lexan cover like this. Replace that with this cover, and we drill out all the specific press down locations on this Lexan cover. Let me just show you a fixture with that type of cover installed so that you get a better idea of what I'm talking about. Okay, so this is the Lexan cover, and it works similar to that. You drill your rod placement here, your pattern of press down rods here, and your bed of nails pins here, and that way the advantage to this is that you don't have adjustables. Sometimes it's not wanted because over the long term, if it's out in production for a long time, or if you send it away to a contract manufacturer, they could change the adjustment of this. They could fiddle with it. So when you lock it down in a drilled hole array, they can't mess with that. It's pretty locked in that way. Now the next type is the edge press. And what edge press does is it presses the board down by the edge. And here's an example of an edge press. Now, basically, move this out of the way and put that in the middle. Your boards go in the fixture like this. Just put them in here. Lock it and press it down by the edge. This presses these boards down by the edge right here, as you can see. Some places, a lot of places, their components out and the edge has to be relieved, but that's okay. As long as you get a good percentage of the edge, then you're fine. And the amount of percentage really matters by the number of test pins used. Now, in this specific application, the boards are long and narrow, and most of the pins are actually on the edge. As you can see here, here are the test pins. These holes you're seeing here are pins that are not installed. The only pins that are in the center here is this one, and this one's not even that far in the center. So 1.5 pins in the center, and then there's one in the center there. Now you can have a lot more than just that in the center, and it still won't bow. But if you have, say, a big board, like what this edge press would be cut out to, you do need some press downs in the center, especially if there's a lot of pins in the center. Well, actually only if there's a lot of pins in the center. If there's not pins in the center, you still don't need that. Now what this is an edge press, and but it's an edge press insert, not a whole plate like you saw there. And the way that works is, another reason this adjustable is so versatile, is you can take that, and this is called T-slot framing. Inside here are square nuts that you can slide in, and you can put this press plate mounted like this in here, yeah, like this actually, and then have it pressed down. So let me show you that a little bit better. So we'll take out these adjustable bank. Now, as I loosened it, you can tell that, the way this adjusts is you can adjust it this way, you can slide it straight up and down, back and forth, and then these can be adjusted this way and that way. So I just wanted to show you that. Just to make, I'm sure you knew, but just to show you. So we'll take these out. And there's 3 of them. And they just lift out very simple like this. And you can position them anywhere you want, as I said, to press it down. So now you have the adjustable section removed on the adjustable fixture. So the way you would do an edge press is similar to this. You'd put this in, bolt this up into the T-slot, and then clamp it down. And from the top it looks similar to this. And these are the square nuts right here that you use to bolt things in. There's just none on the bottom for this specific thing. You have to remove this and pull these out, and then you can put the nuts in the bottom to bolt in edge press on the bottom. Now, to press in from the top, so you have this edge press in here. To press the top, you can then adjust, you can put this back in and adjust the press downs to where they need to be. Or you can combine the two, have something like this in here, and it's got 4 holes to mount it and paper in the back to protect it for now. So you'd put this in, you'd mount your 4 screws here, and you'd drill your pattern here for your press down rods in the middle of the edge press, and you'd have a combination of both edge press with press down rods. So you could press down big square boards with a lot of pins in the middle, not only by the edge but by the central portion as well, using this method. So this adjustable is a very versatile method that can be done very easily, and the reason it can be done so easily, the other fixture, you have to align the press plate and the bed of nails pattern and the press plate pattern quite precisely in order so when you put the fixture together everything aligns. With this, all you have to really do is have the patterns centered. You do your drill pattern here and your edge pattern, and you just have to center your edge pattern here and keep it kind of forward, and then you can adjust it where you need it in the y-axis. So as long as your x-axis, which is that way, is centered, your y-axis has a wide range of adjustment. So it makes it a lot easier to align everything for somebody who's new at building fixtures. Okay, now what I wanted to do is look at the inside. What we did is we covered all the bases for the press plates. We covered adjustable, rods, and edge press. So those are the 3 plates that I wanted to cover, 3 types of press plates. So now let's look at the bases. There's 5 types of bases, and the first one is this single base where it's just a single plate here and nothing much inside. It's mostly for wiring direct to cables out the back panel, and I'll show you the inside of this. Now for the inside, or for this bottom panel, we just take off 2 screws and we have access to the bottom. And the reason you only need 2 screws is because there's some clip on the edge here which also holds it. So it's like there's 3 screws, but there's only 2. But effectively you've got 3 points being held down using that. So the inside of this looks like this. You see a lot of green here. You won't see this on the other fixtures. This whole area is cut out so that you can do whatever modification you want. It's a very universal type fixture. You can put all your pins in here. You can mount some electronics down in here and you wire them out to your rear panel connector. So what I want to do, basically, I want to show you how to take this fixture apart when it's wired up. Because that's the unique thing about this frame design, is you can take it apart when it's wired. So I'm going to fake wire this up. I'll just tape some ribbon wire onto where the test pins would be. So say we have test pins here, wired to some connectors on the rear panel that we don't want to take off. And we're going to take it apart without cutting any wires or undoing any tape. Okay, so now we've got wired to the rear panel and test pins wired to the rear panel, fake wired. So I've already unscrewed 6 of the 8 screws, so we only got to do 2. So we'll unscrew these 2. Now in short, what's going to happen is this rear panel is going to go in and then out the top, basically. So that's the way it's designed, just to go in like that. And the top plate will take off. Now the top plate has 8 screws, 4 on each side. I took out 3 of those 4, so we only have 2 screws to take out. I just didn't want to make you watch me undoing a bunch of screws for this video. So lift the plate out, and let's see if I can do this without blocking the camera. And then take the wires out, and see, we didn't pull or stretch or break any wires. And the front panel works the same exact way. So we have that. Front panel is the same kind of thing, and that would just go in the same way and out. Okay, so that's our basic fixture where you would wire a bunch of connectors to test pins on the plate. So let's put this aside, and I'll show you the next type of base. Now the next type of base almost completely disregards that whole technique, even though it could be done. It's what the next type is to save your work. So when you put a lot of work into a fixture, you might want to save it. Here's the next type. Same basic thing, except that the plate is just this section here. So this plate can be removed, and then you have the internal section is a DIN rail mounted here where you can mount all your parts. This hole here is in case you want to use a gas spring, but a gas spring kind of blocks a lot of the electronics, so we like to use the lift spring, which is this, instead of the gas spring. Now you can put this lift spring on the other one too, or the gas spring, either one. Okay, so the idea is to put connectors on your back panel and mount your electronics on this DIN rail, and then wire from the electronics on the DIN rail to connectors on the electronics that goes to a new connector, then goes out to the test pins on this plate. And you want to keep this because you did a lot of wiring in here. So rather than making you imagine all this, I'm just going to show you. I'll show you one that's partly wired. Okay, this one has parts inside. So here we've got parts inside. We've got a data entry module with Ethernet and USB. Now this USB input here is capped off, I don't know if you can see that, not used because the computer is inside here. And this is just a USB output to peripheral devices like a printer or a scanner, and 12 volts DC output from this power supply for different external devices. Okay, so this is basically a hub here, the USB hub, and that hub connects to all the different circuitry in here. And then we've got a power supply right here, which goes to there. So now all these connectors here you'd plug into here and then wire it out to the test pins. And then to change your plate, you would simply, now the other fixture is the same thing. You'd simply undo these two screws. Actually, 1, 2, 3, 4, 5, 6, 7. 7 screws, and lift this out like that, and your plate comes out. And from the top that you can't really see, it looks like that, and you can see how all your wires would connect to the connectors of these data acquisition boards. So I'll put the plate back in, because this one is actually the third type, and it has another feature where the whole plate can lift up for access, because this is kind of one that's used in a rack. Oh, another thing I want to show you while I have this out here is this is what goes in here, this button module. And this basically put a USB in here, your buttons are all wired up. There's 2 more points here that you wire up to your lid switch. And then with USB you can detect what buttons are being pressed, if your lid switch is pressed, and all this status here can be shown output to the LEDs. Now this is real super basic. More advanced is a touch screen, similar to this. It's a capacitive touch screen. It's got the HDMI and USB for the touch function. And we've got really big ones, and these would be more for the rack mount type fixtures, these big ones. And another thing we could use for rack mount fixture is this insert. It's a blower, it blows air in, and it's got a digital readout for the temperature inside the fixture. This is what a power supply module looks like. AC line in, and then you got your line, neutral, ground, negative, positive 12 volts. Or 5 volts depending on what module you want. Usually people want 12 volts because that's good for hubs and switches and whatever you want to mount inside. If you don't want a power supply, you get something like this and you want a fan, you can have a power input module like this, power switch, and just a fancy, this would say 125 volts, some amount of amperage you're using, and this would only, in the United States, it would say 60 hertz. And then you got your output here. And the neat thing about this output is it's the same as these, which is line, neutral, ground. So you just plug this right in here, this way. It's only plugging one way. And you can mount this on the rail inside the fixture, just like this. Put it in, clip it down, and it's locked in place. So a real quick way to add power to your fixture like that. Well, actually quicker is with the power. This works as well for different types of power supply needs. And we've got a few of these. The fan with the filter on the back. This one you can change it. The filter on the back, on the inside of the fixture, has been the new trend because they don't want the filter on the outside, so people can't just grab the filters and remove them. So there's a screen on the outside, a filter on the inside that's not easy to access. But you can switch it. You can put the filter on the outside. It's real easy to switch over. However, this one, the miniature version of it, you can't switch because this goes up into the unit. And then this one here is a very miniature version where it sucks the air in here and blows it in sideways. Okay, so I wanted to go over the various bunch of peripherals we have for this. Okay, now the next thing, okay, so to show you the third type of base is this button here on the side lifts the whole thing. And it's really handy when it's in for the rack mount because you can lift it up. This can still be connected to all your stuff out the rear panel in the rack, and you can access everything like this. And it clicks in, press this button, it opens. And then, you know, for normal operation, you press it like that. Now, I've been talking about rack mount, so let me show you rack mount as the fourth thing. These can be rack mounted in an adapter. We also make rack mount fixtures specifically designed for that, but here's what the adapter looks like. Now, I've got rubber feet on the bottom here which have to be removed. It's just to protect the bench top while it's being used, while it's being set up. So this would go in the rack and it'd be used inside the rack. Now, let me show you how that's done, because a lot of you may not have seen fixtures mounted in a rack. So I'll slide this over here. Okay, here's a rack. Yeah, that lines up pretty good. So here's a rack fixture. I'll turn the light on. And the way it works is you just test your you test it inside, you run the tester inside the rack. Now this may look a little bit awkward, and it is, because you would do this for low volumes. Now, if you wanted to go a high volume, you just lift these brake, turn off the brake, slide this out, lock it down pretty much anywhere you want, whatever's comfortable. And now you can use it outside the rack. Now you can do some real quick work with it. And it's easy to work with. Now this is really big. It's 4 rack units. Our standard size, this size would be 3 rack units. And the reason for that is because it uses the PXI unit, the National Instruments PXI, which is used for LabVIEW and that kind of thing, for testing like that. So that's what this is set up for. And I'll show you that, a PXI unit inside one of these in a bit. So let me show you more. What this rack mounting system does is it gives a lot of extra workspace, because 3 of these racks can replace 1 bench, and you can have 1 person in front of each one of these racks. So you put your tools in here. Now let me see if you can see that. No. Let me go down a little bit. In fact, go all the way down to the bottom. So if you lost your place, here's the fixture. I'll unlock it. Here's the fixture. Here's a drawer where you can put your tools for working with whatever you're doing. And down here, we got a bunch of equipment. So this would normally be up a little higher. But down here, we've got bins, parts bins. So you can have all your parts bins that you need to add to your boards while you're working with them right here. And it's all neatly covered for no dust and that kind of thing. So yeah, that's the rack mount. And as you can see, this rack doesn't have any sides on it because we're still setting it up. Oh, I don't know if you saw that well. Let me slide that out again. It slides out like this. And you put all your parts in there. Okay. Okay, get back up here and turn it around where we were on the bench top. Try to center everything. Okay, so I wanted to show you rack mount real quick just because that would have been distracting to hear rack mount and not really understand how you can rack mount a test fixture, especially a clamshell test fixture. So when these are rack mounted, you want to open it. You want to be able to access the internals with this side button, like this, and then you can get inside the fixture. And then to operate the fixture, of course, you just do this. Okay, so that's the rack mount adapter with a Prober 6-inch fixture in there. We have these adapters for 2-inch, 4-inch, and 6-inch, and 8-inch. Let me show you a few of them. Here's the 4-inch. It's pretty much, very much the same thing, except narrower here. This is not a 16-inch fixture installed in here. Or is it? Oh yeah, it is. It's a 16-inch fixture installed in there. That's as big as you can get. The 16-inch fixture installed in the rack adapter. Okay, and then I have 2-inch. So you get really small, and this isn't a Prober, this is actually a round fixture, which is a whole different fixture line. I just wanted to show you this for the 2-inch so you have an idea of what the 2-inch looked like. And as for a whole different fixture line, let me show you a Semco fixture. You probably don't know what a Semco fixture is, because nobody calls them Semco fixtures because nobody wants to know anybody to know where they're made from. This is what the startups usually use when they make fixtures for you. If you get a startup company that made a fixture, they'll use a Semco. The Semco fixture is basically right here, mounted in our adapter, and you've probably seen them. That's what they look like. Okay, so you can rack mount that. They got a variety of rack mountable things here. Because when we like to work in the rack with when we do CM contracts, contract manufacturing I should say, because we have limited floor space, and it really helps to use racks, and especially if it's a low volume, you can put it aside, slide the rack into another corner and store it for a while. Okay, let's see. Rack mount test fixture. That's the 25-inch fixtures. They look something like this. So you can see it's a big fixture. And inside, I don't have the bottom panel. I have the bottom panel off so I wouldn't have to spend time taking it off. We've got 2 rails, DIN rails, and you can mount all your electronics in here. Now, this kind of provoked us to build the PXI unit, because we have all our electronics in here, and you can plug your cables into here right into your test pins with about 4 or 5 inches of wire length, really short wires. And a lot of people customers wanted us to put a PXI backplane in here. So instead of making a PXI backplane, which you can't really do legally, I don't think, you can't copy their stuff. You can, I mean, I don't think, I know, you can just put the whole PXI unit in there, and all we had to do was make it one rack unit bigger. So basically, well, let me show you, we have this. So that's what you saw inside the rack. It's just the bench mount version of it without the ears installed. And let me show you the inside. Here's the PXI box, and we've got digital I/O, multifunction I/O. So this would be analog digital. And you just wire from these pins out to your test points right here. And this is the computer. And the way this works is, oh, turn it upside down. Oh yeah, and you can also put boards in here and here, extra boards here if you want, for just extra functions. Now the way this works, I'll turn it on its side, and I'll loosen one of the screws here. Or I only got one screw installed actually, so this slides in and out. Let's see if I can slide it okay on its side. Yeah, it slides okay. So this whole thing slides out so that you can put different cards in. You can pull out your cards, put different cards in, and then, because you can't pull out your cards when you're up here next to the test points. Then you push it in, connect your connectors, and then put your screw in the back to lock it in place. And it's all set. You've got a PXI built into the fixture, and then you can either work with this big thing on a bench top, which with our benches are pretty deep, so they'll work. You can work with it on the bench top or put it in a rack and use it on the rack. And then your front panel, a lot of times it's nice to have like just a grill like this for cooling, and a front panel display like this, a touchscreen display mounted in here, capacitive touchscreen, and basically HDMI, USB for your touch function. Yeah, okay. So that shows, how many bases did I show? 4, right? Yeah, oh, one. Okay, the parallel plates. So, clamshell fixtures test in an arc, and we design it so that there's balanced rake, which means the hinge center pin is level with the center of the travel of the test pin. So the plate contacts it, the plate contacts the test pin at the same point it releases. So it contacts it, presses it down, and goes through an arc, so it goes out just a hair and then back again. And at this point and this point is the same point in travel. So that's clamshell. Now if you want perfect, you've got to use parallel. And this here is parallel. And what it uses is linkages. And the way it works is, they don't want me showing this to the world and China and everything, getting it copied. So it works with linkages. Here. It's patented and everything, but still they still tend to make things. Okay, so this is a kind of an engineering fidget toy we use to train our new engineers on how this system works. It basically works like this. Linkages here make this move up and down parallel. This is not real. It's not none of this is inside of here, but This is a 2D version of what is inside of here. So if you were to extrude this out to 3D, you can see these would be hinges. These two things would be hinges out here. And the center of the hinges would be connected together with a rod. And it would work actually like this. So this plate would be hard mounted to this. And then this plate in here, which you can see. Let me jack that up a little so you can see it. Let's see if you can see that. Yeah, you can see that, okay. So this moves the plate in the inside up and down, similar to this. Now the problem is you can't really see that well, so I'm going to put some tape on here. Help you see this a little better. Put this down. Now this is the thin one has the test pins mounted to it, and the thick one is that bar I told you about that moves sideways. So here's the bar that moves sideways. Here's the one on the bottom plate. Okay. So now you can see that the bottom plate is moving perfectly parallel up and down, and this plate here is moving sideways to keep the hinges in sync. And that's how the whole linkage-based system works. Now this can work two ways. You can put test pins here. They'd of course be elevated a little because they got to be up here. And the test pins are well protected because they come out of holes in the bed of nails plate. And you set your circuit board right down on this flat on the bed of nails plate and pull this, and the pins come up and make contact. Or you can mount a press plate to this and have a press plate up here that comes down when you move it down. So either way, it works like that. But the way this is set up is to work where you press your test pins up. No. You put your board in, clamp it down, and then bring your test pins to make contact. And that's parallel actuation. Okay, so that covers that. That's the 5 fixtures types and the 3 press plate types. And I don't know if there's any more for me to cover here. So yeah, let me just end it with this thing. This would be the more common one, to have the DIN rail inside. And that's the different types of prober test fixtures. Hope this helps, and thanks for watching.